All right, now let's actually make a stem and leaf plot. So question, how do I make a stem and leaf plot? Makes sense. Okay, example, roll one dice twice. The first roll will be the tens digit, and the second roll is the ones digit of a 2-digit number. Okay, reject any first roll that is a 3. Okay, record your numbers in the table below until all the boxes are filled. Cool. Okay, here we go. I'm going to make this table. Let's roll. Okay, I got a 1, so that 1 is going to be in the tens place, and I'm going to roll again, and it's 3. So that means the first little box here, I'm going to make as 3. So 1 second, there we go, 1, 3. Now I'm going to roll again, 6, 3. So this time I'm going to do 60. That was supposed to be a 6, 63. Next roll, 5, 2. So I put 5, 2. I almost have to remember that's a 5. It doesn't look good, but that's okay. 3. Uh-oh. It says reject any first roll that is a 3. So I'm going to reject that. I'm going to do a 6. And then I'm going to do a 1. So this is 61. Sorry, guys, but the technology just doesn't work very well. 61. Okay, next one. 5, 6. I'm sure this is riveting for you all. Just guess what's going to happen next. 3. Uh-oh, reject it. 2, 6. 2. Supposed to be a 2. 2, 6. I have to write very slowly. 4, 6. Come on, Mr. Plunk. Can he do it? Oh! Give him the Academy Award for best writing. Okay, 5, 4. He's going to go nice and slow. He's going to go in there and put the 5 and then put the 4. Very nicely done. 5, 1. He puts down the 5. Oh, he might be going too fast. No, he saves it. Now he does it again. 2, 1. 2. Oh no, he messed up. 2, 1. Okay, we have our data set. We should be good. I'm going to get rid of the dice roller here. And here it is. Make your stems represent the blanks place. Well, looking at our data, how many place values are there? There's a tens place and a ones place. So what do you think our stems should represent? That's right. They should represent the tens place. So I'm going to put tens. Nice and slow. And your leaves are going to represent, well, if the stems are the tens, then the leaves must represent the ones place. Is there apostrophe here? There is, isn't there? I just didn't want to have to put the apostrophe because I'm afraid it's not going to work. Okay, that's the best I can do. Okay, don't forget your key. And remember, you should have no data with a stem of 3. Well, the tens place is in our stems. So do we have any stems that start with 3? And the answer is no, because we were careful. Okay, good. First, order your data from blank to blank. What do we always have to do with our statistics data? We have to order it from least to greatest. We had to do that when we found the median, right? Measure of center, to find the number in the middle when the data are ordered from least to greatest. And all leaves must be in order from least to greatest as well. So on our leaves list here, when we start listing these out, they have to be from least to greatest. So let's go through our data set, and we're just gonna have to go nice and slow. 13 is the smallest, and do I see anything less than 13? Nope, so 13, comma. I'm gonna cross that out. 63, well, 52 smaller, 61, 56, 21 smaller, 51, 54, 46, 26. 21 looks like the next one. And now what am I gonna do? Cross it out. 26, is there anything smaller than 26? No, 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 no. 26. And these are the kinds of places where you'll make a mistake, everybody, so just be really careful. It's worth it. 46 is the smallest I see. Yep, 46 looks like the smallest one. So I'm going to write it down, and then I'm going to get to cross it off. Okay, 52 looks smallest. 51 looks even smaller. 51. 51, cross it out. Next one, 52. I don't see anything smaller than that. 52 or lesser than that. Okay, 54. Woo! Look how good this guy's doing. 56, 61, and 63. Remember our mathematical practice standard number 1, which is precision. So it looks like I have 2 rows of 5. So I should have 10 values, right? I'm really finding the kind of like the area of this rectangle. Okay, how many values do I have here? 3, 6, 9, 10. Good. Awesome. The stems are already written for me. Now, a stem of 1, 3. So I'm going to put a leaf that is 3. Stem of 2, 2, 1, and 2, 6. So 1 for the leaf and then 6. 1, 6. Okay, 4 or 3, we skip 3. 4 has just the 6. 5 has 1, 2, 4, and 6. Wow, 1, 2, 4, and 6. And 6 has 1 and then 3. 1 and then 3. I usually put commas in between my leaves, and it's just so that they don't bunch up and they start looking like one number. So I'm going to put commas. You don't have to put commas, but I put commas just so I see that they're different values. So it looks cleaner. But we can't forget our key. And what I suggest always doing with the key, you don't have to do this. I always do the smallest number. So I look at my smallest stem, which is 1, and then leaf is 3. Well, if the stem is 1, and then vertical line, 3, and let's just not forget that the vertical line that separates the stem and the leaves, and my computer's loading, there we go. The vertical line that separates the stem and the leaves is the exact same vertical line that separates these 2 numbers in the key. So 1, vertical line, 3 is what number in the data set? That's 13. Now think about it this way. What if I had said at the beginning that these numbers actually had decimals in between them? 1.3, 2.1, 2.6. Then this would have been 1, vertical line 3. 1, vertical line 3 would have been 1.3. So the stem doesn't have to be the tens place. It can be any place value. The key tells you which place value it is. So the key tells you which blank value the stem and leaves represent, which place value. Hopefully you heard that just a second ago when I said it. Even if you have no data that has a stem that equals 3. So we have no data that has a stem that equals 3. Since you have data that have stems of 2 and 4, you must still include 3 in your list of stems. This is a mistake students make each year. They go, oh, I have no data that has a stem of 3, so I shall just skip 3 on my list of. No, you can't skip 3. If you have data in the 2s and data in the 4s, you got to put the 3 there, even though there's nothing here. Why? This is a data display. A display is when you can show all the data in some sort of organized picture. And we need to show that 3 because it's weird. We had no data in the 3s, right? And if you are doing statistics, you want to be able to point that out. If you skipped 3, you wouldn't be able to see it. For your key, you can choose any data value in your data set. You could really choose any data value in your data set. I usually choose the first one, that 1, vertical line 3. I could have chosen a 4, vertical line 6, 4, vertical line 6, and said 46 right here. What if the first roll was the 1's place and the second roll was the 10th's place? So if the first roll, the stem was the 1's and the leaves were the 10th's, then 1, vertical line 3 would not have been 13, but would have been 1.3. So careful with that. That key tells us which place value the stem and the leaf represents. All right, I'm going to stop this video and go on to number 3.